Um, Kind of a favorite problem for exams is the following. This is something that combines implicit differentiation with something we covered before, which is a problem where you're giving a function of x defined implicitly, and you're asked to find find the equation of the tangent line at a given point, and in the graph, um, corresponding to this relation between x and y. So when it is let um, y cubed plus xy e to the x squared minus 9 be equal to 4. So y here again is defined implicitly in terms of x, but you cannot solve for y in a close way. You cannot just simply write down y is equal to some expression involving x. And so but what you're asked to find, but this will have a certain graph. I mean, since there's one near a given point in satisfying this near a pair xy satisfying this relation, here nearby there will be a graph passing through that point, and that graph corresponds to y of x, to the function y of x. You can use a computer to do that. I mean, this is not necessary for the problem at hand, and of course, if there's a graph, I mean, in the function is differentiable, then you can find the equation the equation of the tangent line. This is precisely what you're asked to do here. So find the equation of the tangent line at the point 3, 1. So the first thing I told you in the previous video that you need to do when asked to solve a problem of this kind is to check that this point actually belongs to the graph determined by this relation. So first, this is the first thing. Is in the graph. Well, is it? Yeah, so we need to compute y here is 1, so 1 cubed plus x, which is 3, times 1, we're computing this now, times e to the x squared minus 9. X is equal to 3, so we get 3 squared, which is 9. I'm going to write this down like this. And here, well, e to the 0 is just 1. This is 0. So e to the 0 is just 1. And now, if you add 3 times 1 times 1 plus 1, you get 4, which is exactly what we have on the other side. So this is actually checked. So the 3 comma 1 is in the graph. So now we remember from previous sections, what do we need to do in order to find the equation of the tangent line? Here. To find the equation of the tangent line, we need 3 things. The point A, f at A, and f prime at A. So now what's the difference here? The difference here is that f is not given to us explicitly, but a is known. A is the value of x, so a is equal to 3. F of a is known to us. Remember that y is function of x, so this is f here is equal to y. So it's y of 3, which is equal to what? According to this, it's equal to 1. So that's the value of the function. So this is equal to 1. And we just need to find f prime of a. So remember here. So in f of x f of x is y of x. And to find the derivative, we just proceed like we did in the previous problem, and then we'll be done with the, just remembering the steps of finding the equation of the tangent line. And so for that, we just need to find the value of the point, which is given to us is the first value here in this pair. And the f of a is just the second value, so 1. And to find the derivative, we just proceed like in the previous problem, and we'll be done. And whenever we see x and y, we need to plug in these values, 3 and 1. Okay, so be very careful. This is a very important part now. F of x is equal to y. So since we're going to be differentiating with respect to x, this is something I want you to pay special attention to. This is something where I see when in problems like this one, I see many people making the same mistake and forgetting that we're differentiating with respect to x, and then y is a function of x, and they differentiate wrongly and they don't obtain what they were supposed to be obtaining, or sometimes they don't even have an equation for y prime. So again, to find y prime, we differentiate implicitly. Again, this means that we're taking the derivative on both sides. The derivative of a constant is 0. We already know that. So 4 prime is 0. Here we have to be careful now. So when we take this derivative, this is the derivative of y cubed with respect to x. xy e to the x squared minus 9 prime equals to 0. Here remember, we're differentiating with respect to x. We're going to use the chain rule. So this becomes 3y squared times y prime. This 3y squared is just the derivative of y cubed with respect to y, and then we need to take the derivative of y with respect to x. Remember, we are differentiating y cubed with respect to x, not with respect to y. And this is the mistake I see very often, that people when differentiating say a power of y with respect to x, they just write the power rule and forget about the y prime, which comes from the use of the chain rule, which is the correct thing to do. And then the other terms, you also don't forget that we're differentiating with respect to x, not y. So we apply the product rule, and the first term it just becomes 1, right? Because the derivative of 1 of x is 1 with respect to x. E to the x squared minus 9 x, and now the derivative of y with respect to x, so y prime, e to the x squared minus 9. And finally, we have xy times the derivative of e to the x squared minus 9. And we apply the chain rule there, and we have e to the x squared minus 9 times the derivative of the exponent, which is 2x, and that is equal to 0. So now, what is y? Now we substitute everything here. So y is equal to 1. So we have 3 and 1 times y prime plus 1 times y times e to the 3 squared minus 9, which is 1. Remember that x is here equal to 3. X is 3 then, 3 y prime, e to the x squared minus 9, again it's just 1. And then plus 3 times 1 times, again, 1 times 2x, which is 2 times 3. And that whole thing should be equal to 0. So we get this like term, so 6y prime plus y, remember y is equal to 1, just 1. Here we have 6, 18, so 19 is equal to 0. So y prime is equal to minus 19 over 6. So when we know this, the equation of the tangent line, is y minus f of a, which we know is 1, is equal to f prime, which we just computed, minus 19 over 6, times x minus 3, which is the value of the point that we used. And, well, that's it.